Hello everyone. Today I'm going to simulate of uh, innovative 3D radio circuit. Before designing a innovative 3D radio circuit, I have designed a simple 3D radio circuit in which very few functionalities was mentioned, but uh, I have designed that circuit with some modifications and adding some instructions which you will see in couple of few minutes. So let's start. Uh, Here, for making a innovative project which is based on stability circuit, we choose Arduino Uno board. This is Arduino Uno board. Here, you can see that there are 14 digital pins and one ground pins in upper rows and one ARF pins. In opposite side, we see that there are six analog pins and some of the power pins, in which two pins are ground, one pins for 5 volt supply, and another one pin for 3.5 volt supply. There are also two pins are available, which is for reset and IO RF. Here is a microcontroller, which is uh, built in Arduino Uno board. If we're talking about the power supply of Arduino, so there are different ways to power supply of Arduino. Here, this is a USB cable. Through USB cable, we insert our instructions, or we can say coding, through Arduino IDE software to Arduino Uno board. And another section is provided in Arduino, which is that here it is a power jack. So through power jack we can supply Arduino up to 12 volt. Now, now we go to the next component, which is a PI sensor. It is a input tap device which detects the any type of motion under the range of 8. So you can see here there are three pins in a PI sensor. Uh, uh, one uh, one is a signal pin. This one is a signal pin. Here it is a signal pin, and another pin which is for power, and the last pin which is for ground. Now, our next component is buzzer, which is used to simply create a sound. But um, after adding some coding, we also generate sounds in different frequencies, in form of different frequency varieties of sounds. So it is totally based on our programming skills. Here, three registers are also used by me, which have a rating of 1 kilo ohm. Now, another uh, equipment which is used by me, which is uh, LED, which is RGB. That means red, green, blue. This LED blinks into three different colors, which is red, green, and blue. So here we use LED as an indicator for our project. Now, Uh, Now I'll switch over to the power supply, which is 5 volt. But if we mm, uh, go for our hardware implementation of our project, then we power supply to our domestic world through AC. And here we also use a relay. Relay is used for high load driving purposes. You can see the rating of this relay: 3 ampere or 125 volt AC, and it is also used as 3 ampere or 24 volt DC. Now you are already familiar with domestic bulb, but in nowadays LED bulb is more preferable. Um, if we're talking about coal electricity bill. So now we also use a macro servo motor. In this macro servo motor, there are also three pins as like a PI sensor. This is a ground pin, and middle pin is called a power pin, and another pin which is used for signal. Here, in our project, micro servo motor is used as a reference of door or window. So now, our next component is breadboard. Here, breadboard is used for interconnections of various wires. In breadboards, the upper rows are all interconnected to each other. You can see here. If we click on one hole of negative sign of rose, then it shows like a green rose. That means it is interconnected to each other. Similarly for plus sign also. Now in another half, if we go for holes of middle set of Arduino, then you can see here the all columns are interconnected to each other. Here we use a register whose rating is 220 ohm, and also use a potentiometer which is used for varying a voltage for LCD displays. Now, here we use the LCD displays. It is output device. So, any message I want to show here, we can display here. So for this, before displaying any message, I need to insert programming in our Arduino IDE software. So through Arduino IDE software, those instructions will go to our Arduino Uno board, and Arduino Uno board, according to our instruction and or coding, uh, it will give signal to LCD displays to display some messages. So here, with the help of potentiometer, we generally operate the contrast level of LCD display. Now, uh, mm, I come to the connections of our project. So first, we discuss about PIR sensor. So, as I already told you, there are three pins in PIR sensor. Uh, One is a signal, power, and ground. So, in signal pin, we connect we connect this pin with the digital pin number 6 of Arduino Uno board, and power pin is connected to the breadboard, and another ground pin also connected to the breadboard. Here we supply Arduino we power supply to or a PI sensor to Arduino. You can see here. Uh, uh, Here it is a one wire, 5 volt, one wire which is goes through the 5 volt pin of Arduino to uh, breadboard, and here the power supply goes through it, and here through this red wire the power supply uh, will go to this wire also. Similarly for ground. So I have indirectly power supply to PI sensor with from Arduino IDE. And also we know that the Arduino IDE power supply in Arduino IDE are various forms. So here we can we uh, in present we use a USB cable for power supply to Arduino Uno board. Generally, it supply to it's 5 volt uh, 5 volt supply to Arduino board through USB cable. Now, if we're talking about our buzzer, so here also we connect the ground pin of which is negative side to the breadboard, and positive terminals connected to the digital pin number 9 of Arduino LED, RGB LED. The cathode terminal of RGB LED is connected directly connected to the ground of Arduino Uno board, and the red terminal is connected via 1 kilo ohm resistor to uh, digital pin number 8 of Arduino Uno board. Similarly, for blue pin of uh, LED connected via 1 kilo ohm resistor to digital pin number 13, and green pin connected via 1 kilo ohm resistor to the digital pin number 10. Now we're talking about our domestic bulb. So here we connect the terminal number 2 to uh, terminal 5 uh, 5 uh, uh, 5 of relay, and this digital terminal 12 is connected with the positive um, power supply with external power supply, and the negative uh, of external power supply is connected uh, with the first terminal of our domestic bulb. Here, the terminal 8 of relay is connected directly connected with the Arduino Uno board through the digital pin number 8, and also digital pin number also the pin number that means terminal number 6 of relay is directly connected to the ground. You can see here this wire goes into the Arduino Uno board and connected with the ground pin of Arduino Uno board. Now, I have seen the connection of PIR sensor was a LED light, domestic bulb, relay, and power supply. Now, I am talking about micro servo motor connections. So, for micro servo motor connections, we directly supply uh, 5 volt to Arduino Uno board from 5 volt pin of Arduino Uno board, and ground pin is directly connected with the ground pin of Arduino board. You can see here. For signal, uh, we connect the signal point of micro servo to the digital pin number 7. Here you can see. Now, uh, there are many connection in LCD displays. You can see here. So, if we talking about our LCD display, there are 16 pins. Here, it is ground, which is connected with the terminal number 2 of potentiometer. VCC is connected with power supply line of breadboard, and contracts for the varying contracts. We connect this terminal point to the wiper of potentiometer. It is a wiper through which we varying our contract level of LCD display. Now, this is a register select pin which is connected with Arduino digital number 12. You can see here, this is a 12 number pin of Arduino is connected with the register of LCD display. Now, read write pin is connected with the ground power line of uh, um, breadboard, and here it is a enable pin, which I show here in yellow for from yellow wire. So here this wire is connected with the digital pin number. This wire is connected with the digital pin number 11. You can see here digital pin number 11 of Arduino board. Here uh, uh, we leave the 4 points of LCD display. So after that, DB4 point is of LCD display is connected with pin number of 5. This is a green wire. So digital pin number 5, it is connected, and DV5 which shows here in uh, from the blue wire, it is connected with 4. Similarly, DV pin number DV6, it is connected with the 3, and DV7, it is connected with the digital pin number 2 of Arduino. Here, this is a LED anode pin, and it is a LED cathode pin. So this LED anode pin is connected with the 220 ohm resistor, and this resistor is connected with the power line of breadboard, and here LED cathode is connected the ground line of breadboard. So I have completed the all connections available in our project. Now, uh, I, so I will going to the simulation part of our project. So, before it, I will want to explain my codings with the connections. So you can see here. If we're talking about our codings of our this project, So this is very long coding. So if you want to apply this coding in your project, so it will be available with my video description in my video description link. So briefly, I will want to discuss these codings. Here, we use two types of library file, which is the liquid crystal.h and servo.h. Because we use an LCD display, so we use LCD crystal.h. And also in our project, I am using a servo motor. So for this, I need the servo.h library file for our coding purposes. So it is servo initially position is 0 and servo 7. That means it indicates that here liquid crystal LCD 12 11 5 4 3 shows the digital pin number, the Arduino digital pin number 12 11 5 4 3 2. Now these characters these characters for used these codings for use for displaying the uh, special character in LCD displays. So, uh, this is for a smiley character, and this is for heart character, uh, frowning character, and this is for arms down, and this is for arms up in LCD displays, which will you uh, show in simulation portion. Here we use a pin mode 6 input. That means our digital pin number 6 of Arduino Uno board is used as an input for Pir sensor. Pin mode 8 output, that digital pin number uh, 8 is used as the output. So you can see here there are two connections from digital pin number 8 of Arduino Uno board, one for relay and another one for buzzer. So, and digital pin, no, sorry, digital pin number 8 is used for uh, LED. LED. So digital pin number is used for two outputs, one for relay and another one for LED, uh, for red pin terminal of LED. Similarly, for digital pin number 9, also used as the output, which is used for which is using here for buzzer, piezoelectric buzzer. And pin mode 10 output denotes that is the pin number 10 is used as an output for LED pin, green LED pin of Arduino and LED, green pin of LED. And pin mode 13 output, that means Arduino Uno board of digital having a digital pin number 30 is using as an output for blue pin of LED. Then servo 7 attach 7, that means the signal pin of servo motor is attached with the digital pin number 7 of Arduino Uno board, and here LCD begins 16 by 2. That means our LCD starts working as here. The dimension for LCD is 16 by 2. So here in LCD, we display different characters. One is a smiley, frowning, arms down, arms up. And, so in the first simulation portion, LCD print I and then LCD write white 0. That means white 0 hot. So that means I and then it hot display after all guess and there it display LCD write white 1. Here you can see a white one, that means smile. In while loop, in sensor reading analog read A0 and map the result 200 to 1000 in digital time, map sensor reading 0, 1, 2. So these are for LCD displays and LCD write 3 delay then 1000. It is a for it is a in from a millisecond. So LCD is cursor for one. Then LCD write 4 and now digital write 8 load. That means the equipment connected with the digital pin number 8 of Arduino Uno board firstly de-energized. So you can see there are two components, relay and red LED, red pin of LED. Then both are de-energized firstly. And if digital write 13 high, that means the component connected with the digital pin number 13 of Arduino Uno gets energized. That means high. So here the blue pin of the blue pin of LED is connected, so it works as it's glow. It start glowing as it starts start of simulation portion. Similarly, for digital pin number 10 is low. Digital pin number 10 is used as a green pin of LED, so it will not glow at the starting of simulation. Then servo 7 right 90. That means the servo motor which is connected with the digital pin number 7 of Arduino inverter rotate at 90 degrees. Then here we use a if condition. So in if digital pin read 6 equal to 1, that means if our Pir sensor which is connected with the digital pin number 6 equal to 1, that means uh, feels some motions, detects some motions under its range, then it gives signal to Arduino. Then Arduino then works for our Arduino works for digital 8 high. That means red pin of LED and relay both will work. Both will be working, and digital write 10 is low and serial write 13 also low. Then servo motor 7 is write 0. That means servo motor rotates at from 90 to 0 degree. Here LCD starts working 16 by 2. So here firstly LCD display hello Pacific, or we can also add any message uh, for as our convenience, and then it uh, shows delay by 2 seconds, and after that LCD clear. LCD will be clear. And another condition is using for creating the different sounds of buzzer. So, so here no tone 9. Digital pin number 9 Arduino what is connected. and tone 9 is connected. So here we use here note tone 9 shows the digital pin number 9 for connection of our buzzer. 8 880 which is used for frequency with 880 hertz frequency, and 200 shows the delay which is 200 milliseconds. Next line, our frequency will be 988 hertz and delay will be 500 milliseconds. At last, our frequency will mm, go for 1047 hertz and 300 millisecond delay. Then health conditions here come. So if our Pir sensor don't detect any motion, so in this case, digital pin number 8 gets low. That means connect here you can see here from digital pin number 8, our LED red LED pin will not glow. LED not glow red color and really not working. That means bulb get diffused, bulb get off. So, and in this case, servo motor also rotate 90 degree and from 0 to 90 degree, and actually cuts to 0 to 0. In this case, we print I byte 0. That means byte 0. That means hard, guessed, and byte 1, uh, which is used for different characters. And the digital writing high here, that is red, green pin of LED will start glowing, and it is provided delay for 1 second, and then digital pin number 13 high. That means blue pin of LED will glow. Blue LED will glow blue color. So this is a completion of our coding part of our project. Now uh, we will show the simulation part for our project. So uh, for this this here you can start this simulation from here. So clicking on this button here, you observe here our LED bulb starts glowing in blue color, and servo motor rotate at 90 degree from 0, and LCD display I heart guest, that is I love guest, and with smiley face here you can see that. And here the one character is uh, rotating its hands, arms up and arms down. Now we observe some we will observe some motions for Pir sensor. So for this, um, we click on the Pir sensor. So here now this point shows the motion. So if we rotate it, then Pir sensor, then you can see the bulb is start glowing, and LED bulb um, is glowing in red color, and buzzer also starts creating sound. And if we uh, Talking about our LCD displays, so here you can see here, uh, if someone the motion is detected, then you can see here there is different message is showing in LCD displays in case of motion detection by PI sensor. So it is worked like that. And now, if we're talking about our servo motor, then we take as a reference of door or window. So here, in first case, we start simulation. Then our window uh, was open, or then any motion is detected by a PI sensor. Then uh, servo motor rotate from 90 to 0 degree. That means it will close. That means our door automatically closes according to our instruction. And you can also observe here for in LED bulb, in case of motion detection, our LED bulb glowing in red color, but the motion is not glowing, then it will glow as first green and then blue. So blue color is used here in general purpose, uh, general form, and once PIR sensor detect any motion, that detects any uh, warning, any mm, any casualty, then it shows red color, and then our casualty, then any motion will remove uh, from a PIR sensor, from the range of PIR sensor. Then it glow as for then glow. It then it's create a green color, which shows that our mm, device or our security area is safe. This green light shows for safe zone. That that means I am in now. I am in safe zone. And then after some delay, blue color will display will glow from LED bulb. So this was all about our project. Here we discussed about all uh, possible or important part of for our project. So we will meet in hardware implementation in next video for our project. Then thank you. Thanks for watching this video.